Hello everyone, and welcome to the AI Research Roundup. I am Alex, your host, and today is May 7th, 2025. We are looking at a research paper from Hugging Face's trending list, published just 5 days ago on May 2nd, titled Improving Editability in Image Generation with Layer-Wise Memory. This paper tackles sequential image editing, making multiple changes while keeping everything consistent. It proposes a framework using what they call layer-wise memory. This memory stores the AI's internal understanding of the image and text from previous edits, helping new objects blend in and the background stay coherent. Alright, so this first figure really sets the stage. On the left, you see examples from existing tools, like Photoshop and other image inpainting models. When they attempt sequential edits, the results can often look a bit disjointed. Then, on the right, we see the author's method in action. It shows them building an image step by step, using intuitive rough masks and text prompts. First a forest, then adding a Lego man, a jeep, and finally a dog. The final image looks remarkably coherent, showcasing how their layer-wise memory, storing latent representations, which are like the AI's internal compressed understanding of the image, helps maintain that crucial consistency. Building on that layer-wise memory, this next diagram really unpacks the system's core. We see it sequentially adding items, a cupcake, then a mug, and finally a dish, to a wooden floor scene, all guided by simple text prompts. Two key components are highlighted. First, background consistency guidance, or BCG, which uses those stored latent representations from the memory to keep the background stable during these edits. And second, multi-query disentanglement, or MQD. This operates within cross-attention layers, which are parts of the AI that help it relate text prompts to specific image regions, using saved prompt embeddings, the AI's understanding of the text, to ensure new objects blend in naturally. Okay, so speaking of that background consistency guidance, this table offers a direct computational comparison. It pits their background consistency guidance approach against a more standard image editing technique called latent blending. The comparison focuses on two key performance measures: processing time in seconds and VRAM usage. VRAM, or Video Random Access Memory, is the dedicated memory on a graphics card, essential for these AI tasks. The numbers show that background consistency guidance is noticeably faster, completing the task in about 3.9 seconds versus over 4.1 seconds for latent blending, while using virtually the same amount of Video Random Access Memory. This really highlights its efficiency. So to properly evaluate these iterative edits, the authors introduce their multi-edit bench, detailed here. Part A shows its data generation pipeline, selecting object classes, defining layouts, and using a large language model for rich prompts. Part B then covers evaluation. Visual alignment is checked using contrastive language image pre-training, or CAI, model linking images to text. For semantic alignment, how well the meaning matches, they employ LLAVA, a large language and vision assistant, to calculate scores like Bilingual Evaluation Understudy, or BLEU, and Meteor, which are metrics assessing textual correspondence with the prompt. So, with that comprehensive multi-edit bench for evaluation, the overall picture is quite compelling. This work really moves the needle on sequential image editing. The core innovations, that layer-wise memory which remembers previous steps, the background consistency guidance ensuring the scene stays coherent, and the multi-query disentanglement helping new objects fit in naturally, all contribute. Ultimately, this approach allows for more intuitive and powerful image editing, clearly outperforming older methods in keeping things consistent and looking natural. That is all for this AI Research Roundup. Thanks for tuning in.